Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over another problem where I'm going to calculate the Gibbs free energy change and predict the spontaneity of a reaction based on its delta H and delta S, its enthalpy change and its entropy change. So let's get into this. So in this video we're going to consider this reaction here where we have C2H4 gas reacting with H2 gas to form H2 or C2H6. So they're giving us, or we have here, the delta H of negative 137.5 kilojoules, and the delta S, the entropy change, is a negative 120.5 joules per Kelvin. So here we see that the entropy is decreasing and the enthalpy is decreasing during the reaction. So let's see what effects those have on the change in the Gibbs free energy. So what we are looking for a spontaneous reaction is a negative delta G. If we get a positive delta G, that means that it is not spontaneous. So we're going to use the equation here for delta G. So delta G is equal to delta H minus delta S times the temperature. So they're giving us 25 degrees Celsius. So what we need to do is change that to Kelvin. So 25, so let's do this. So temperature is equal to 25 degrees Celsius. And we're going to add 273 to that to change it to Kelvin. And so that's going to give us 298 Kelvin. So now we got our temperature. They're giving us delta H. Notice that the unit for delta H is kilojoules, whereas it's for entropy, it's joules per Kelvin. So if we're gonna put these right, if we're gonna use these to calculate, we need to make sure that they're in the right units, or the same units at least. So let's convert kilojoules to joules, because delta G is going to be in joules. So we want that in joules. So let's go ahead and convert that to joules. So they're giving us a negative 137.5 kilojoules. We're going to use our conversion factor. 1 kilojoule goes on the bottom, 1,000 joules on top. So kilojoules cancel out. Now I have joules, so I calculate that, and I get negative 1.37 times 10 to the 5th joules. So there's my delta H in joules. So now I can plug everything into my equation and find out what I get for delta G. So then delta G is going to be equal to the delta H, which I just calculated here. So that's going to be a negative 1.37 times 10 to the 5th joules. And then I'm going to subtract out, and then I have a negative 120.5, so that's going to be a negative 120.5, and that's joules per Kelvin. And I'm going to multiply that by T. Here, let me give myself some space here. Yeah, let's go ahead and rewrite that down here. So let's say, okay, delta G is equal to, again, negative 1.37 times 10 to the 5th joules. And I'm going to subtract out that 1. So 120.5 joules per Kelvin. So let me write this. Sorry about this. Let me write this so it's clear. So again, it's negative 120.5 joules per Kelvin, and that's going to be multiplied by T. Okay, so now I can solve for delta G. And then, I forgot. T is for temperature, and so we got 298. So that's going to be multiplied by 298 Kelvin. So 298 Kelvin. And so when we multiply this out, we get a negative 1.37 times 10 to the 5th joules plus, and we're going to end up with a positive 35. So 3.5, I think it's 909. That is correct, 3.5909 joule, or times 10. Let's see, times 10 to the 4 joules, right? So here the kelvins canceled out. So now we have joules. We add these together and we get a negative 1.01 times 10 to the 5th joules. So this, ladies and gentlemen, is our delta G. It's negative, so that tells us that we have a spontaneous reaction at this temperature, 25 degrees Celsius. So next question is asking us, does delta G become more negative or less negative as the temperature increases? So we got to look at our equation here. So here temperature is multiplied by the entropy, which is which is negative. So all of this part of our equation is negative because of the negative sign. So we're subtracting this from the delta H. Our delta H is negative, which makes this part negative. But since our delta S is negative as well, the negative times the negative gives us the positive here. So as the temperature increases, this part is positive. So that means that our delta G is going to get more positive as temperature goes up. So at some point, at a higher temperature, as the temperature goes up, at some point that temperature is going to become high enough so it's going to overcome the negative delta G here, and then delta G will become 0. And then above that temperature, you'll now have a non-spontaneous reaction. So you can go ahead and calculate what that temperature is. So to answer this question, does the delta G become more negative or less negative as temperature increases? It becomes less negative. It becomes less negative because, as I said, as temperature increases, this is negative, that's a positive. So as the temperature increases, delta G is becoming more positive, or another way to say that is less negative. Or another way to say that, more positive. More positive. So you could answer the question also, it's like, okay, at what temperature will this reaction no longer be spontaneous? So in that case, we know that the delta G, as temperature goes up, delta G is becoming less and less negative. So then it's going to become 0 at some point. And then above that temperature, it'll be positive. So at what temperature do you make that change from negative to positive? Well, let's see. We can set delta G as equal to 0, since that's the point at which you stop being negative. So delta G is equal to 0. And again, we'll use our equation, right? So that's going to be equal to delta H minus delta S T. So now all we need to do is plug in our delta H and delta S again and solve for the temperature. So let's go ahead and do that. So then delta H is the same as before. So delta H, our negative 1.37 times 10 to the fifth joules. And that's going to be minus, and again, our delta S is the same, minus negative 120.5 joules per Kelvin. And that's going to be multiplied by temperature. But we don't know what the temperature is at delta G. We can figure that out. So now we can solve this equation. So we're going to bring this over here to this side, right, by adding. So we're going to add 1.37 times 10 to the fifth joules. And we're going to add it to this side here, plus 1.37 times 10 to the fifth joules. So this cancels out. So now we have 1.37 times 10 to the fifth joules. And that's going to be equal to this side. Negative times a negative gives us a positive. So that's going to be positive 120.5 joules per Kelvin. And that's going to be multiplied by the temperature. So now all we need to do is divide both sides by the positive 120.5 joules per Kelvin. So let's go ahead and do that. So 120.5 joules per Kelvin. Divide this by 120.5 joules per Kelvin. The joules here cancel out. We're left with Kelvin, which is what we want. So now when we do the division, we can get the temperature. So then the temperature is equal to, give me a moment while I calculate this out. Okay, so then you calculate that out and you get 1,100, what was the calculation? 1,137 Kelvin. So that is the temperature you would have to raise this reaction to in order for it to not be spontaneous. That would be the temperature at which, above that temperature, it becomes non-spontaneous. So at that temperature and above, it will be non-spontaneous instead of spontaneous. So I hope that was helpful. If you enjoyed this video, if this video was helpful in any way, then please, by all means, like the video, share it with your friends, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all for all my videos. And then also, last but not least, leave me a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.